Ça marche?
Hi, I hope you had lots of fun with the competition. So before going into the award ceremony, where we will see what happened during the last hour, we will talk a bit about the contest, and so the judges will describe the problem that they have designed, how to solve it, etc. Okay, so let's start. These are a few statistics about the number of
Very classical. You have to count the number of occurrences of strings and just check if there was a string that appeared more than n over 2 times. The simplest way to do this is using an hash table, and there is another solution with the Boyer-Moore algorithm where you don't need to use the hash table, but still you have to keep track of the data because you have to check afterwards that the candidate you found appears more than n over 2 times. But it was a very easy problem.
Okay, so the third one was also a quite easy problem. It was solved by many teams before freeze, and first by rubber duck forces. Okay, so the problem is known as a minimum excluded. So you are given a set of integers, and you must find the smallest natural number which does not belong to that set. And of course, you can store all the numbers in some hash table, but a better solution is to use a Boolean array. And the only tricky part with this problem was to handle negative or very large numbers that were part of the input. And a more interesting challenge would be to solve it in place, which you may try to do.
Thank you. The fourth solved problem before freeze was iceberg, first solved after 15 minutes by UPC1. Okay, so the problem was we are given n polygons and we want to compute their total area. We quickly see that the polygons can be treated separately, and which means that the problem boils down to computing the area of one polygon. So let's take a polygon and let's suppose it's clockwise. We want to compute the area. We see that if we draw in blue arrows going right and in red arrows going left, then what we want to do is to compute the blue area and remove the red area. So to compute this area, we use the following formula on a given segment, which is computing the average of the two y and multiplying by the distance in x. Okay, so if we do that for all segments, we see that for blue segments it will be positive, and for red segment it will be negative. which means that we actually get the green area with this simple formula. So there is a question about what happens when you have a polygon that is not y-convex, such as this one. So we drew blue and red segments, and then we add the blue on top, then we remove the red, then we add the blue, then we remove the red, and we see that we have gotten everything that we wanted, that is the area. Now there is a final question about what happens if the polygon is given counterclockwise, and we see that everything in the formula reverses and is negated. So we can get the area of any polygons using an absolute value. Thank you.
So birdwatching was solved by 22 teams, before freeze, of course. And first, after 40 minutes by ICPC 1. This was a slightly more challenging problem, but still a traditional graph algorithm. So the question was to find all the paths from one vertex in a graph to another that is predefined, but excluding the paths that exist from n to t. So you take one predecessor of t, the target node, and you want to find the node where the only path to t is the edge between n and t. So a naive approach would be to iterate through all the predecessors of t, remove the edge going from n to t, and do a DFS to check if you can still reach the source node. However, you would have to do the number of vertices, DFS, and each DFS is going to take e time, so that's v times e, and given the limits, that will be 10 to the power of 10 operations. It's too much. So we need to find a way to cut the search and have a less expensive algorithm. To do this, an idea is to consider a different graph where you remove all the edges leading directly to node t. And you will see that the solutions are the nodes where you cannot find any other node n prime, where there is an edge from n prime to t in P, and in the auxiliary graph where we removed all the edges into t, there is a path from the node we're considering to n prime. So in my example, you can see that A is not a solution because you have another node B which leads to t, and so you would have a path from A to t through B in the original graph. However, for the other node n, you have a solution because there is no other path. So you consider this auxiliary graph and you run a DFS from the predecessors of t, but you know that you can stop the search as soon as you have found another node n prime. And that lets you cut a lot of branches. So you could consider, for example, a set of predecessors of t that you can reach from your node n in your second graph. And you run your DFS, and as soon as you reach two nodes, you can stop. This cuts a lot of branches, and it's enough to solve the problem.
So this problem A was solved by 19 teams before the freeze. It was first solved after 43 minutes by Uniboys. So it was actually quite a classic graph problem. So we had a graph. You had to build a graph out of the coordinates and the costs and the Euclidean distances, in which we have two distances, actually, the CO2 cost and the Euclidean distance between the stations and the source and the destination, right? So the particularity of this problem is that we couldn't just solve some shortest path taking into account only the CO2 cost or only the Euclidean distance, because there were cases in which the shortest path, like there, would cost too much CO2. The cheapest path in terms of CO2 would be too long. And there are cases in which you have to choose a combination of two. Can you, Pierre? So the simplest way to solve it would be to naively we would have to generate all the shortest paths and take shortest path in terms of distance and take the one with the least cost, but that would be too inefficient. But we can do something else. We can run a Dijkstra algorithm on the graph constructed out of the CO2 cost, but prune all the paths that are too long, that are outside the distance budget. Thank you.
All right, so the counting tree problem was solved by 11 teams and was first solved at 48 minutes by team ENS Ulm 1. So the problem was to count the number of integer labeled binary trees which have the min heap property and have a given integer sequence at their in-order traversal. So this is called a Cartesian tree. So the basic solution that you can think is a dynamic programming solution where you compute for each of the subsequence of the given sequence the number of Cartesian trees. But the complexity is bigger than cube, which is too slow for the time limits given for this problem. So there is a better solution. And in order to explain this solution, let's imagine I want to count the number of trees for this sequence. So first you have to locate the positions of the minimum of the sequence, and for these, well, you will arrange them at the top of the tree, essentially. And the number of arrangements that you can find for these elements is a Catalan number. And then you call recursively the algorithm for each of the subsequences that are delimited by the minimum of the sequence. So if you implement this naively, you get an algorithm in big O of n square. And if you use a min-range data structure, you get a quasi-linear algorithm in n log n, which is already good for this problem. But it appears that there is, again, a better solution. So to understand this solution, first you have to notice that the solution is a product of Catalan numbers. And each of these Catalan numbers correspond to a group of n elements of the sequence. And each of these groups is characterized by the two properties that are here. The first property is that they all have the same value. And the second property is that they are not separated by a smaller element of the sequence. It turns out that these groups can be very easily computed using a stack in one pass over the sequence. This gives a big O of n algorithm, and it is very short because you can implement it in 15 lines of very simple Python code.
Okay, so the next one was called a pseudo-number random generator. It was solved by only 4 teams before phrase, and first solved by Last Tatale of Blue. Okay. So you are given a pseudo-number generator with a function which basically computes a 42-bit unsigned integer from the previous one. Okay, and you have to count the number of even values in some prefix of that sequence, but the n can be quite large. Actually, it can be up to 63. Sorry. So the idea is that the sequence of numbers will cycle necessarily eventually, since you have finitely many values. Okay, so you can compute the start of the period and the period, and the idea in that problem was to compute that before submission. Okay, so you can compute these numbers, and then when you have these numbers, you can even pre-compute the number of even values for blocks in the sequences, okay, in the first part and in the cycle, okay, and then you can submit a code which makes use of these pre-computed values to speed up the computation, okay. So now you are left with the problem of finding the period and the start of the period. Okay, so this can be costly, especially if you do it naively. Okay, if you store all the values, it will consume too much memory. But you can use Floyd's cycle detection algorithms, also known as the tortoise and hare algorithm. Okay, and which is briefly depicted here. You traverse the sequence at speed 1 and 2 until you get an equality. And then there is a matter of actually finding the exact start of the cycle and the length of the cycle with a second loop. If you want the details, you'll go to CNUS to see how to compute these two values. And once you have that, you can pre-compute all these values, and now you can answer in constant time.
River game. So it was a pretty hard problem solved only by 2 teams before freeze. EP Chopper was the first team to solve it at 133 minutes. So the problem is as follows. 2 players take turn to place cameras on a grid. The grid is composed of 3 types of squares: firm ground squares, wet zone, and protected zones. And there are a couple of rules to place the cameras. Importantly, the rivers have properties as well on the length. So the max length of a river is 2n. And also the rivers are at least 3 squares apart. And the question is to say who will win the game, assuming both players play optimally. Next slide, please. So a brute force solution could look like this. The state is the n times n grid, where you keep track of the cameras that are already placed, and then you recursively compute who will win. But if you do this, you end up with a complexity of 2 to the n squared, which is too slow. The key idea to a faster solution is first to define shores, which is a connected component of firm ground squares adjacent to a given river. So if you look at the picture, the rivers are in blue and the shores are in orange. And shores are the connected component of the firm ground squares adjacent to a given river. And the key observation is that cameras on a given shore don't affect placement of cameras on other shores. Hence, you can decompose the game into k independent games, where k is the number of shores, which is less than n squared and usually much less than this. You can compute the Grundy number for each shore, which can be computed in s times 2 to the s, where s is the maximum shore size. And then the position is losing if the XOR of all those Grundy numbers is 0. You can also bound the number. Sorry, you can bound the maximum size of a shore.
Raphael, maybe you can say what the Grundy number is. No, not everyone. Maybe you can say what the Grundy number is.
Our chief judge doesn't know what is a Grundy number.
So a Grundy number is a way to make this problem equivalent to a game of NIM. So I don't know if you're familiar to the game of NIM. It's a game where you have multiple stacks of items that you can take, and each player can take as many items as he or she wishes on a given stack. And the first player that cannot take any item loses. And so from a given state, you can compute a Grundy number for a given shore, and this tells you what is the equivalent size of NIM stack. Yeah, so you can bound all this, and at the end, this way you can get some algorithm that runs fast enough. Yeah, so here's quickly the way you can compute a Grundy number for a given state.
First, you compute the list of possible next states. For each next state, you compute the corresponding rounding number recursively. And then you take the smallest non-negative number that is not present in this set, which is, by the way, the exact same algorithm as the problem ants. And of course, you can add memorization on top of this so that it doesn't explode.
The problem swapping places was solved by 3 teams before freeze, okay? Starting with UPC1 at 145 minutes. Okay. And so, I mean, here you're given a word, and you have some pairs of letters in your alphabet that can commute with each other. And so, I mean, each word is equivalent to another bunch of, a big set of words, and you'd like to find the first word within that class for the alphabetical order. Okay. And so the constraints are that the word is long, but the alphabet is small. Okay. So basically what we would like to do is, maybe just find the first word of that target word you want to write, and then find the second letter, the third letter, the fourth letter, etc. And to find the first letter, what you need to do is you look at all the possible letters in the alphabet, and look at those letters that commute with all their predecessors. Okay? And if a letter commutes with all its predecessors, then it could be swapped to the first place. And so you will choose the lowest letter that commutes with all its predecessors, and it will be the first letter of your minimal equivalent word. Okay. And then, so once you have found it, what you can do is that now you assume that you have moved that letter to the left. Okay. So it was mu in my example. And then you can just assume that you erase it from its original position of your word. Okay. And now, there were some letters that it did block from going to the front, and that it does not block anymore. So in practice, what you can see is that you can recompute, which is the initial domain, which is a prefix in your word, on which each letter of the alphabet could commute with everybody. Okay. So that's what you have to compute. And so here I have a toy example, okay, just to show you how it works. So starting from the word 341 to 31, and you assume that 2 commutes with everybody and 1 commutes with 4, for instance. So first, so basically the letter 1, it does not commute with 3, so it's already blocked by the 3. It could not go from farther right than this 3. But letter 2, it commutes with 3, 4, and 1. And so now, your prefix you are computing is blocked by the first occurrence of the 2. Same for 3, and for letter 4, it's blocked by the first occurrence of 3. Okay. And then, so, those 2 letters that could go to the left are the 2 and the 3, and you will select the 2 because it's smaller, okay? So you erase it from the letter W, and you put it in your W bar, which is your target word, okay? And now, it does not increase which prefix you could have for letters 1, 3, and 4, but for letter 2 it does, okay? And then you can do this process again. So now the least letter that can go to the left is the letter 3. You select it, you erase it, and then you continue letting your prefixes W1, W3, and W4 going further to the right. And you can just, if you look back at the slides, you can see that we construct again the word W bar. Okay. So you can just let every prefix row. And so the entire computational cost of this is just the sum of the lengths of the prefixes at the end of the algorithms, which is the size of A times the size of the word W, and so this is manageable. So up. So this. Okay. And so you could do the problem this way.
So the last problem that was solved before freeze was Knockout, solved by 8 teams, and first by METH after 161 minutes. So if you read the name from right to left, you can see it's stack lang. So it's actually a stack language where your programs work on an infinite stack. But here the programs are pretty small, limited to 10,000 instructions. So you're only interested in stack of about 10,000 elements. Values are either pairs or non-pairs. And you are asked to prove the equivalence of 2 programs. And the instructions are pretty basic. Copy, drop, swap, pair, unpair, left and right. Some of you have understood that what the letters meant. And left and right are just syntactic sugar for USD or UT. So the solution is to use a technique called symbolic evaluation. So you will evaluate the program on a symbolic stack made of symbolic elements. So you just number the input stack from 1 to 10,000, and you just execute the program, and it gives you an output stack. So the evaluation is linear in the size of the program, but then you have to compare the two stacks, and comparing can be expensive because it's linear in the overall size of the stack, not only the number of elements but also the size of the elements. So it can be very expensive. In case of pair copy, pair copy, you have exponentially large values. So the solution for these large values is to see that you can build at most 20,000 different values, so you can give a unique identifier to all of them, and you have to give the same identifier if you build the same value from the same elements. So if you build a pair from left and right that are the same, you have to give the same identifier, so you can then compare them efficiently. So the comparison of the stack becomes linear. You can even do better if you encode stacks as pairs as the top element and the rest of the elements. So it becomes even simpler to code, and the comparison is just constant time.
So finally, pixels. So obviously, we all froze in this amphitheater before it was solved. Okay. So we'll have a surprise or not, I don't know yet. And so the problem is just you're given a grid of black and white pixels, okay? And originally all of them are white. And in the end, you have a target grid, so some of them should become black. And you also have a family of controllers, so each controller will change from black to white or white to black a given set of pixels. And so your goal is to know which set of controllers you should press if any does the job. Okay. And so the limits that we have is that basically the grid and both initial and target are quite large. Okay, so they have up to 100,000 elements. But then each controller controls only a few pixels, and they are arranged along a grid. So I mean, you do have some kind of regularity which should be used later. And in practice, I mean, basically the algorithm we will have, it will work in times k times L times the smallest of KL, which is still feasible. Okay. And so an approach is to see that, I mean, black or white is just 0 or 1, so you will work modulo 2. Okay. And then, so your initial and final grids, there will be vectors on the field with 2 elements. And then, so now, I mean, every controller, it's just adding some vector, let's say, because if I control 5 pixels, I just add 1 to the color of these 5 pixels. So a family of controllers is just a family of vectors, so a matrix. And finally, deciding if I press a set C of controllers, I can identify this set of controllers with some vector. And so my problem becomes a linear algebra problem. Okay. And then I should use Gaussian elimination, and it's a bit tricky because I have to use the sparsity of my matrix and the fact that I did have some regularity with my grid. But if you do it in a clever way by doing drawings, let's say, I mean, in the end, the Gaussian elimination works and does the trick. And so you do have the wanted time complexity for this problem.
Thanks to all the judges for the design of the problems and for the evaluation of the problems. There wouldn't be much contest if there were no problems in the contest. Okay, we can move on to the award ceremony. And we are using ICPC tools that work in a stochastic manner, so I needed to launch it 3 times for it to work. Okay, so we are going to look at what happened during the last hour of the contest. Before that, let me mention that the contest was also public. There were members of, your coaches and also members of the general public who participated in the contest. And some managed to solve all the problems. So I hope contestants also managed to solve all the problems. So this is the scoreboard as it was before the freeze. So as it was before the last hour of the competition. And so we are going to look at it from top
to bottom.
And we are going to see whatever happened during the last hour of the contest. So as I mentioned, teams that are not eligible because they were not complete are not part of this final ranking. So let me explain how this works. You see things in green, in yellow, in red. In green, it means that a team solved it before the freeze. In red, it means that he didn't manage to solve it before the freeze and he didn't attempt to solve it after the freeze. And in yellow, there were attempts to solve a problem after the freeze. And you can see the total number of attempts before the hyphen, and afterwards you can see the number of minutes from the start of the contest. So for instance, 292 means that it was attempted 8 minutes before the end of the contest. So we are going to look first rather quickly and then a bit more slowly at what happens with, for instance, this team had a submission like this and they managed to solve it, so they go up in the ranking.
Université Grenoble-Alpes moving up.
Université Paris 8, no submission. Université Paris 8, one submission and they go up.
University of Verona.
University Grenoble-Alpes, one submission, not successful.
University Juan Carlos.
Paris 7, one submission, not successful.
Paris Sud, going up.
Artois University, one submission, not successful.
Sorbonne University, one submission, failed.
URJC, successful.
Beira Interior, not successful.
Effray, not successful.
Venice, not going up.
Valencia, not successful, 1 minute before.
École Centrale de Lyon.
Valencia, not successful, not successful.
École Centrale de Lyon again has 2 submissions, but they're not going up.
UAM, 3 minutes before the end, nope.
Murcia has 2 submissions, but no.
ENSTA Paris, nope.
Università di Trento is going up.
Padova, 2 submissions before the end, 2 minutes and 1 minute before, nope.
Polytechnique Sofia has 1 submission. Yeah.
Sorbonne University, 3 pending submissions, just minutes before, nope.
Artois University has 1 pending submission.
ENSTA, 3 submissions, nope.
Centrale Supélec has 2 pending submissions and they are both failed.
Centrale Supélec also failed as well.
Télécom Sud Paris has 1 pending submission.
Epitomat Epita, nope.
Paris 8.
Finished. Paris Sud, nope.
URJC, nope.
Trento, 1 pending submission, and goes up again.
Politecniche di Milano.
UPF, 1 pending submission.
Paris 7 has 1. Yes, they go up.
Paris-Saclay, no pending submission.
Genova, nope. Nope, yeah.
Paris-Saclay, 1 pending submission.
Roma La Sapienza has solved all of the problems. Or have they?
Madrid, no pending submission.
University di Bologna has 2 submissions and they don't succeed.
Milano, 1, 2, nope.
Polytechnique Sofia has 2 pending submissions, but...
And set 1 pending submission, nope.
URJC again, they're finished.
Rennes, Isir, 1 pending submission, but not successful.
University of Porto, nope.
Rennes, ENS de Rennes, 2 pending submission, nope.
Bologna, nope.
INS Lyon, 2 pending submission, no.
ENSTA Paris has no more pending submissions.
Trento, 1 pending submission, and go up.
Our host Telecom Paris has 3 pending submissions, but they're finished.
Technion, 2 pending submissions, nope.
Politecnico di Milano has 2 pending submissions.
Montpellier has 1 pending submission, not successful.
INSA de Lyon has 3 pending submissions, but they don't go up.
University Paris Sud, nope.
Université Paris Diderot Paris 7 is finished.
University of Verona, yes, they go up.
INS Lyon.
Padova, they go up as well.
INSA Lyon again, and they go up again.
Faculty of Engineering Porto, nope.
INS Lyon has 3 pending submissions, 5 tries, and they're finished.
Trento stays there.
Paris 7 stays there.
Lisboa, 2 pending submission, and they go up.
INSA Lyon.
Verona stops here.
Padova has 2 pending submissions, and they go up.
Trento, no pending submission.
FC Porto has 2 pending submissions, but they're finished.
Scuola Normale Superiore, 1 pending submission, and they go up.
Haifa has 2 pending submissions, and they go up.
INS Paris-Saclay, 2 pending submissions. Nope.
They're finished. University of Trento is going up.
UPC 3, they go up.
Rennes 1 has 2 pending submissions.
No,
and
yes,
they go up.
EPFL, no.
Telecommander is finished, but we stop here because...
Because there is something in dark green. Dark green means that this team was the first to solve problem B, just a small 3 minutes after the beginning of the competition. So they are awarded a special prize, first to solve problem B.
Will Telecommander, Telecom Paris, please come on the stage for a special prize?
Après, c'est le stream, moi je contrôle rien.
Oui, j'espère. For your speed in solving problem B, you are awarded a special box of Lego.
To share between you and to build a lot of things. Okay, let's continue in the ranking.
Right.
So we are at position 30. So far, everything down to position 30 is fixed, but things above can still change.
Yeah.
So let's go up. SNS 3,
no
more correct submission.
Luis is finished.
INSA Lyon, a lot of pending submission, but at the very last minute, it's very
so much
serious.
Talent. But Jay was too hard, apparently. UCM is finished.
No more. Murcia, 1 pending submission. We are going to take things more slowly now. We are reaching the 25th place. So let's look at the first problem. Problem A, they attempted to solve it. Did they manage to solve it? Well, yes. So they go up in the ranking. Now,
all right, we're again at place 25, but this time it's for UCM. Well, yeah, they have 2 pending submissions. Let's see what happens to the first one. Nope. And the second one is a yes, and they move up.
We are still at position 25 again. It's still not clear who will get this position. We are with University of Lisbon. They have 1 pending submission. Is it successful? Yes.
There is a lot of competition for the 25th place, but it goes to SNS2.
So congratulations to SNS2 for the 25th place.
Congratulations, SNS2, for the 25th place.
Okay, we are going to the 24th place, no pending submission. Congratulations to Unity and TM2 from Trento for the 24th place.
Yeah. We now go to position 23, and it goes to University of Haifa with no more pending submissions. Congratulations.
The size of the pictures is just an effect of the stochastic nature of the tool we are using. It doesn't mean anything else. Okay, 22nd position now. There is a pending submission for SGSS on problem K. Did they solve it? Yes.
Yeah.
So we're back
the
at
22nd place could go to University Politecnica de Catalunya, but they have one pending submission on problem J, and no, they didn't succeed. But congratulations for the 22nd place.
Okay, let's move to the 21st position, and no more pending submission. University of Rennes 1, and they were the first to solve the problem I, so as before, a special prize for them. Please come down.
Please come to the stage, University of Rennes 1. So Rennes 1 and Telecom Paris are tied. Huh?
Rennes 1 is stick.
Rennes 1 is stick, sorry. Rennes 1 is stick and Telecom Paris are tied for being the first to solve any problem of the contest, I think, with 3 minutes on 2 different problems. Congratulations for the 21st place and first to solve.
Okay.
All right, moving on to the 20th place with École Polytechnique, EP0. They have 2 pending submissions, one 1 minute before the end, and it fails. The other one also fails, sorry, but they get the 20th place.
Okay, let's move to the 19th position. There was no more pending submission from the Unidos Comemos Macarons, and so they get the 19th place.
All right, moving on to the 18th place with Roma La Sapienza, but they have 2 pending submissions. One of them is 3 minutes from the end, 5 tries on problem J, and it fails. But on problem K, they go up to the 8th place.
UPC2 has many pending submissions left on problem A. Goes
and
up.
They go up. So the 18th place goes to Universidad de Murcia with 6 solved problems. Congratulations.
Uh, 17th place, no more pending submission. École Normale Supérieure de Paris, INS Culminante, 17th place.
Congratulations. Moving to the 16th place with Politecnico di Milano, but they have 2 more pending submissions in the last hour. The first one is a yes. They move up.
Okay, 16th place again. IST Epovoses has 3 pending submission on problem J.
Yes. They move up. So 16th place again. So many things happening in this last hour of the contest because we still have 2 pending submissions for Università de Bologna Unibois. The first one on problem D, 12 minutes from the end. Let's see. They go up.
SNS 1 has 2 pending submission on problem A. Nope. On problem G. Nope. So 16th place for SNS 1, Scuola Normale Superiore.
Yeah.
Let's move to the 15th place.
The 15th place is currently at Technion Israel Institute of Technology, but they have 3 pending runs. The first one on problem D is failed. The second one on problem J is failed. One on problem L is a success.
So we go back to this 15th place, and from here on, all teams have solved at least 7 problems in 5 hours, which is extremely impressive. And so no more pending submissions for the team codified from the University of Lisbon. So the 15th place goes to this team.
Yeah. This team with an unpronounceable name is the only team to have 7 solved problems but no medals, so sorry for them. This is a unique title of their own. So now let's move on to the 14th place and we start handing out medals. So remember, we have 2 gold medals to distribute, 4 silver medals and 8 bronze medals. The 14th place is the first place to get a bronze medal, and Padova has, well, no more pending submissions, so they will get that place. Please, could you come to the stage to receive your medals? In the interest of time, we recommend that teams who expect to get an award can prepare themselves to be ready to jump on the stage when their turn arises. Congratulations, guys. The bronze medalists get a gift of external batteries and also a special gift from our previous sponsor, Palantir. Congratulations again, University of Padova.
Okay. And they have 2 more balloons. Let's go forwards and move to the 13th place. So no more pending submission for Sapienza Black Universidad di Roma La Sapienza. So also bronze medal and 13th place. Do not flee the medals.
I mean, by the first place, hopefully we'll have figured this thing out. Okay. Congratulations again, Sapienza Black, Universidad di Roma La Sapienza, 13th place, bronze medalist.
Okay, we are now at the 12th place.
Moving on to the 12th place with Politecnico di Milano, but they still have 1 pending submission on problem J. And they move up to the 7th place currently.
So back to the 12th place, 2 pending submission for UPC2 on problem D. 2 minutes before the end. Nope. On problem G, sorry. My French is interfering. On problem G, they go up.
They go up. So for the 12th place, Bologna could still surprise us with a last minute, like literally last minute submission on problem J. 10th try, did it work? Did it work? Nah, it didn't work. Please come to the stage, University of Bologna, Uni boys.
So first to solve the problem A, in addition to being a bronze medalist.
Yeah. And we have a stream and we have like cameras and stuff, but it's not, anyway, we're still having fun and stuff and figuring things out as we go. What? Not quite. Whatever.
Okay, congratulations. We are reaching the 11th place with IST, who still have 2 pending submissions on problem J and L. So on problem J, it's successful.
Yes. Look what happened. We have reached the top of the rankings, but we still don't know what's going on above the blue line. But for the 11th place, there is no surprise. It goes to Rubber Duck Forces from Technion. Please, Rubber Duck Forces, please come to the stage. So I'm sorry, we don't have any prizes for the duck, though. We are, of course, the volunteers are handing out the balloons that were not delivered because of the freeze, so that the teams can parade with all of the balloons that they have earned during the 5 hours of competition. We see that they have, several ducks, actually, so that's why there's also many problems. There were 6 of them. Congratulations again, Rubber Duck Forces from Technion, 11th place, bronze medalist, and first to solve problem D. And congratulations to the whole Technion delegation. Thank you.
Okay, now we are on the 10th place. There are still 2 pending submissions for University of Milan. On problem D, yes, it's going up.
Why did the people wait until the last hour to solve so many problems is beyond me. Like, were you doing something else or what? So anyways, 10th place goes to Universitat Politècnica de Catalunya, UPC 2. Yeah, congratulations again, UPC 2, bronze medalist, 10th place. You want to keep it for yourself? Oh, no.
Congratulations. Okay, position 9, Maura Donnelly, Political Milano, no pending submission, so bronze medal and 9th place.
Yes. With 2 problems solved in the last hour, apparently, judging by the number of balloons you are now being given.
Congratulations.
Yeah, congratulations again. 9th place. Well done. We are now at place 8, and it could go maybe to IST, unless this last-minute attempt at problem L. No, sorry. But we still have, yeah, a bronze medal to give to you.
There is a suspicious number of balloons going on.
Yeah, the best successes are always team efforts, so I see that you were helped in arranging this huge stack of balloons with a... Wow. Oh, well.
Okay, congratulations.
You will always remain in our hearts and in our amphitheater, I guess. We are now, whose turn is it? Okay,
I can't remember the alternation. Let's look at position number 7, where ethanol from ETH Zurich has 2 pending submissions on problem G and on problem H. On problem G, it's... Sorry. On problem G, it's successful.
Move up. So we don't know yet which one of meth and ethanol is the most effective to solve programming problems. We will figure this out when we get closer to the top, although we're already pretty close to the top, actually. This is the last position where the teams would be getting a bronze medal, the 7th place. And the 7th place could go to Università degli Studi di Milano, La Statale Blu, unless... Ah! Aha.
Okay, so 7th place again. We are reaching INS Ulm 1, which has 3 pending submissions on problem G, on problem K, and on problem L. Let's see what happens. On problem G, 2 minutes before the end. Nope. On problem K, 18 minutes before the end. Is it the last minute attempt? And they go up.
No one wants of these bronze medals, apparently. So now it's time for Upi Rouge to tell us whether they want a bronze medal or a silver or a gold medal. And they have 3 pending submissions. The first one is on problem G, 7 tries, last try 1 minute before the end. Could have guessed that. Problem H, 2 attempts, and yeah!
So we are again in place 7 with the last minute attempt by ethanol at ETH Zurich, which we saw earlier. And we are looking at the... there is some suspense. What happened at the last minute? Oh no. Okay.
Congratulations again. Ethanol ETH Zurich, the best of our bronze medalists.
So we are now moving to place 6, and from now on it's silver medals.
But then there's no surprise there either, right? La Statale Blu has no more pending submissions. So the 6th place and a silver medal goes to the Università degli Studi di Milano. 6th place.
And first to solve problem H.
So our silver medalists get external hard drives as gifts, plus a special umbrella gift from Palantir. Congratulations again to Università degli Studi di Milano, 6th place.
Congratulations.
Silver medal.
And we didn't insist on it, but the team in position 7 and onwards have solved at least 9 problems, which is, again, quite impressive. So we're moving to position 5. So we are seeing back INS Ulm 1. And they have one last attempt at problem L. About 20 minutes before the end.
Let's maybe remember that these are the winners from last year, so they have a
they
title
were
to defend.
last year's winners. And they go up.
So by now, a careful reading of the scoreboard would suggest that the winners of last year will not be the winners of this year, and that the SWERC trophy will have to be relocated from ENS Ulm to a different place. But we still have to figure out which place. But for now, let's turn back our attention to the silver medalists and place number 5. IP Rouge, so this is the second of the École Polytechnique teams that we are seeing in the scoreboard going from the bottom, still has a pending submission on problem L. And...
Okay, so we'll get back to them a bit later, and we now look at Metz from ETH Zurich, which has also one pending submission on problem L. Let's see what happens. Let's see if they solve 10 problems. Yes.
So meth is really better than ethanol, apparently. We go back to the 5th place with our winners that are back to the 5th place. So this is their final ranking. ENS Ulm 1, École Normale Supérieure de Paris. Please come to the stage to receive a silver medal. ENS Ulm 1.
Also first to solve problem J.
Yeah. Maybe this is a good opportunity to point out that we do not have knowledge of how many teams will proceed to the World Finals. So last year there were 5 teams, including the institution Porto that was hosting the World Finals. So the number of teams of SWERC to the World Finals will probably be between 1 and 5, and I'm afraid it's all that I have to say about this.
So this is decided by ICPC. There is also a rule of ICPC that an institution cannot have 2 teams participating into the same World Finals.
Oh, I wonder why you remind us of this now, but
I don't
that's
know.
an interesting fact. Anyways, congratulations again, yes, ENS Ulm 1, 5th place, silver medalists, and first to solve problem J. And thanks for bringing back this nice trophy. You will have other chances to reclaim it, maybe.
Okay, now we are at position 4, and so there are no more pending submissions for École Polytechnique IP Rouge. And so the 4th place and the silver medal goes to IP Rouge.
So we are now in the territory of teams who have solved 10 out of 12 problems. This is an average of 2 problems per hour, and I'm running out of adjectives to describe what I think about this, but this is, yeah, I don't know, incredible, wonderful, miraculous, anyways. Congratulations again, École Polytechnique, IP Rouge, 4th place and silver medalist of SWERC. All right, let's see. It's again my turn to go back to meth. And meth is now out of its magical powers. They have 10 solved problems, like IP Rouge and ENS Ulm 1. And they are the first to solve problem D. Congratulations, meth, ETH Zurich. 3rd place of SWERC, silver medalists, and the first to solve problem D.
Sorry for the picture, you were not all there when you had your picture taken, so it's a bit partial.
Is this some kind of recipe on the blackboard? And I wonder what's happening.
Congratulations.
Congratulations. 3rd place, meth, ETH Zurich, silver medalist of SWERC. An outstanding track record for ETH Zurich.
Okay, so we're moving now to the first 2 position and to gold medals. So both first both teams ranked in first and second position currently still have pending submissions, so we don't know what is going to happen to them. So let's first look at UPC1, and it's very interesting for UPC1 because they are the only team of the whole contest to have attempted to solve problem E. No? Oh yeah. They have seriously attempted to solve problem E. Sorry for
the only top team, let's say.
Okay, so let's see if they were successful. It's only 7 minutes before the end. Did they manage to do it 7 minutes before the end? And yes, they did.
Let's pause here and reflect on how amazing this is. 11 solved problems out of 12. They are the first to solve 4 of these 11 problems. They have solved what? They have solved 4 problems in the first 15 minutes of the competition at minutes 4, 6, and 9. But so we are now at second place again, and we have still to find the right position between our 2 gold medalists. And it's like a kind of duel in a Western, and we have seen one of the 2 cowboys shoot, but let's see what is the second cowboy doing. It's the last trick up EP Chopper's sleeve. It's their last pending submission on problem D at minute 276, and this is basically their only chance to get to the top, so it all hinges on that. Who wants to know? Oh!
So congratulations to École Polytechnique. But first, let's go back to UPC1. So now the ranking is final. There are no more chance to change the ranking. And so UPC1 is a gold medalist of SWERC, is second place, and first to solve problems E, F, G, K.
So the gold medalists of SWERC get another kind of gifts. In addition to probable World Finals qualifications, they get gold medals. They get a Bose portable speaker. They get a special water bottle gift from Palantir, and they also get a special gift by our sponsor, Nomadic Labs, of a cryptocurrency wallet, if I'm not mistaken.
And a bag that you can use to store your other prizes.
Congratulations again to the second place of SWERC UPC1 Universitat Politècnica de Catalunya. Second place, gold medalists, 11 solved problems, and the first ones to solve problems E, F, J, and K. Impressive achievement.
Okay, and now we are at the very top of the ranking. No more pending submission. So the first place, the title of SWERC champion and a gold medal goes to École Polytechnique for team EP Chopper.
Please, everyone, applaud EP Chopper, the SWERC champion of this year. EP Chopper has solved 11 problems, and they're the first ones to solve this extremely challenging river thing, problem L with Grundy numbers or whatever that is. And oops. Don't break these precious water bottles from Palantir, please. And they also get the trophy. Congratulations.
So École Polytechnique will keep the trophy until next year. Luckily, they don't have very far to go, so it will not be a trouble to carry the trophy with them.
Yep, the trophy remains in Paris for the time being, but in a different school.
Very close to here.
Yeah. Yeah? Yeah?
Hi everybody. Today I'm very happy for 3 reasons. The first is because I won SWERC, and actually it's my first participation, so I really tried a lot. Like the first participation, on the second I didn't have anything. The third I had a bronze medal, and today I have a gold medal, so I'm very happy. The second reason why I'm happy is because of my team, because they are both they are very excellent, and they are both bachelors at Polytechnique, which is a new program. So it shows that the new bachelor program at Polytechnique is really good. And the third reason, and the third reason why I'm happy is for the school, because I don't think it has happened in many years that Polytechnique won the SWERC. It hasn't happened in many years.
It has actually never happened, so it's the first time it happens.
Okay. Then, I don't know if it happened, but over the 4 years I was at SWERC, no school won both gold and a silver medal. So I'm quite happy about that. I don't know if it happened before. Okay.
I don't have the whole history in my mind, but the history is on the SWERC website.
And finally, I'm really happy because I think, so 4 years ago, after having quite a bad result at SWERC, I decided to organize trainings at Polytechnique. We worked a lot with the teachers to provide new classes dedicated to prepare the SWERC, to have hours to prepare the SWERC, to have ECTS credits and things like that. And I'm really happy that I think we have such a great result as a school and not just as a team, because we had this great preparation over the years. So I want to thank everybody at Polytechnique. So Eric Goubot, Adrian Kozowski, and Hang Zhu, with our coach now. And just one last thing. One last thing. So I would say that just before just after the lunch, just before the award ceremony, I was interviewed by some I think volunteers, and they wanted to know if I had any advice to give to the future SWERC contestants. So my advice is to share your passion about computer science. So yeah.
Okay, congratulations again to the SWERC champion for the 2019-2020 edition.
Oh, well. No. These problems were fake. See, they run away. Anyways, so we have our winners, we have our rankings, and everything is almost over, except it's now time for the closing ceremony, and our word of thanks to all of the people who have helped make SWERC possible. I now give the mic to Bertrand Meyer, the Deputy Director of SWERC, for the closing words.
Yes, unfortunately, it's really time to part. We have a few words we want to say before you all going home. First, well, we hope you enjoyed your time here. There is something new that is changing in contrast with last year's. We are not printing your certificate today. We are going to do it more relaxed during the week and send them if you tell us where to send them. So if you want to receive your winning certificate, please let us know by...
We will send you an email, and you will just have to reply to the email to let us know where to send them.
And then it's also time to say a big thank you to all of the people that have helped us for the organization of this event. So the first people we would like to thank are our sponsors, because not only they are providing us with their generosity to organize this thing, but as you have noticed, they have been there yesterday and even today, and this was really kind of them to come and to attend to this event and to be with us for this. So we would like to thank JetBrains, who is sponsoring the Global Foundation of ICPC, and our local sponsors. So remember, we had people from Atos. So thank you to Atos, thank you to Jane Street, thank you to Mazars, and the representative is still with us today. We had also many other bronze sponsors. We had research sponsors that were also helping us a lot with our budget, and this was definitely useful. And yeah, well, as I said, we were happy that it was not just their support, but also that they sent people to be with us, and it was really nice to have those people that came to the event. We have had some helps not only locally but in other places. So the medals are, it's becoming a tradition that Porto is bringing the medals here. So I don't know if you find it annoying, but it's useful to us, so thank you. Maybe you would prefer that we take care of our... Yes, of course. We had also like the help of the ICPC headquarters. Veronica was here to help us, and the people from ICPC Live, Lydia, Pavel, Nikita and Camille for the live broadcast that you might have, well, that your coaches might have seen on their computers. So thank you to all of you who have been helping us to make this possible. We have people taking pictures, cameras and so on, so thank you to Comet. And we're waiting for the video. It will take some weeks to process, but then you will find them on YouTube. So thank you to Comet also.
They're just behind you, I think.
They're behind, yeah. Okay, looking for you. We've had many help also, many help from people at Telecom, so a lot of people have helped us from the logistic for the partnership and the development of the school, for funding, also for communication. So thanks, a lot of thanks to all these people. We had even more the need and the help of the people of the IT group here, and they were with us during the contest, and they have been working even today to make sure that all the setup was working, that the network was doing good. So thanks to all of them who have helped us for this. And then I need all the volunteers to come to the stage. Where are they? So please come to the stage, all the volunteers.
Please come to the stage. Congratulations, we don't have any medals to give out to you. But yeah, you would really deserve one. Not all of the volunteers have been able to stay today. Not all of them were here today because SWERC has been organized over the last 3 days by them. They have been supervising the rooms, moving stuff around, setting up the school, posting signage, inflating balloons, delivering printouts, preparing bags, preparing badges, all of these tasks. We are extremely grateful to you guys. Thank you.
Yeah, every time I believe that slaves will not work as hard as they are working, but we have really exploited them, and well, we are happy that they are still alive, and really thank you to all of you. I can't imagine how many miles or kilometers you have walked in the corridors and how many boxes you have carried, but really a big thank you to you, because this is really thanks to you that we could manage to do all this. So really thank you. And we had an amazing team of judges. Please, judges, come to the stage. They are the ones that we are hiding and that we're never showing to you because we don't want anything to leak. But now it's time to present them to you. So if you had fun, if you had a hard problem to solve, it's thanks to them. And please give them a really big round of applause too. And the last people we wanted to thank, and you should applaud them too, is the coaches. Because, okay, you came here to enjoy the competition, but all the work, usually all the hard work is done by your coaches, and I think they deserve also a big thank you when they're going to take you home. So thank you to all the coaches. So thank you for coming. We were really happy to have you here in Paris.
Logistical information.
Logistical information before you go home. We have the leftover snacks that are in the
hall. I suppose,
in the hall.
yes.
So if you want to help us more, please take some food with you. It can be useful for your trip. And the buses are going to be probably in I don't know if they're here already, but the buses are going to be as they were yesterday, to bring you back to 3 places. If you are in a hurry to go back to Paris, your best thing to do is to get off at the first stop, which is going to be Massy RER, which is quite close to here. And the connection should be easy. And then the buses are continuing to a second stop that is going to be Porte d'Orléans. And the last stop, so the third stop, is going to be in Gentilly at the Joe & Joe hostel. But if you want to connect with public transport, you can do it in Massy. And at this hour, we have not checked the traffic jams, but it's likely that it's easier to take the... in terms of time, it's likely that it's faster to be on the area.
So, of course, organizers forgot to thank themselves. So we really need to thank a lot to the organization committee, which is here, essentially. So thank you a lot to Louis Jassier, Pierre Senelard, Antoine Amarelli, Marc-Jean Mougin, Bertrand Meyer, who worked. You can't imagine how much work they put in this event, so please thank them a lot.
Thanks everyone. Organizing this thing is a lot of work, and but when I see you again after all the preparation that goes into SWERC, I remember why we're doing this, and yeah, thank you so much. I'm really happy that you were here. Have a safe trip back, and see you next year somewhere to see who will be the next owner of the trophy of SWERC. Thank you.